So, recording in progress. It's Saturday, the 10th of August already. We're like halfway through the month. We're like, I don't know what's going on. It's insane. Hot as heck here in Texas. It's like over 100 degrees, which I know for some people down in like Arizona and stuff, they're like, balmy sunny day, but
yeah,
I don't like it. I don't like it. We'll talk about a few different things going on here. And I really want to make sure that we have some opportunity to talk about projects and that kind of thing. But today's topic, not was brushless and brushed motors. I don't know that's actually anything that we really kind of touched on specifically. So I thought it'd be a really good idea to talk about that, the mystique behind it. I know there are a few people here who have probably spent their entire RC skipper career using brushed motors, and brushless maybe, witchcraft or whatever you want to call it. So we'll touch on that topic. I did a little presentation, and then we'll open it up because there's a high population of people who are going to be here today who've used both and can give an unbiased opinion about utilization and pros and cons and all of that kind of stuff. Something that did crop up before we started recording and before a lot of you got on was ferrites. Now, if you had a chance to take a look at my last update video, the Virginia was having some weird behavioral issues. When I kick the main drive motor on, the pump, the ballast pump would kick on intermittently. And I thought there was like a polluted main power bus, and I thought maybe the ESC was bad. And then I got to thinking, I'm like, it's the first thing that somebody's going to tell me I should have checked. So you know what, I'm just going to do it. And sure enough, I snapped an iron ferrite over the signal wire of the pump electronic speed controller, and it completely and utterly rectified the entire issue without any problem. So, and I don't profess to be like an expert in EMP and electronics and that kind of thing, but you got to understand, we're working in an enclosed environment, right? We've got a cylinder with a lot of wires and power and signals and delicate electronics that are all trying to talk together in a cohesive manner. What can happen, depending on how you've routed your wires and how sensitive the electronic modules are to interference, there can be issues when you have a lot of power going through in close proximity to signal wires in particular. So there's this thing out there, a magical device called a ferrite, and there's a few different versions of it. The one in my video was a snap-on ferrite. You can clamp it over an existing wire, and basically it grounds out, nullifies EMP signals that propagate through the wires to cause interference. There are also disc. What's that?
It's called a choke.
Electronic choke. There's also disc versions of that, which are a little simpler and very likely exponentially cheaper. But you gotta thread the cable through it and kind of make like a loop, a couple of loops through it.
Like a transformer, it's an inductive device.
Right. You're like when we do tanks a long time ago, we were getting interfered because everything's in an enclosed space, and you're inducing a lot more power than you are with most of the level of submarines that we do. We braid the wires to cancel out those signals, right? So we braid everything out, and because we were getting not only inducements to other functions, but also especially with radio signals.
So define braid. What do you mean by when you braid the cables?
Let's say like you take your your wires and you got a four band strand of wires, you separate them out and you actually braid them, right? Instead of being linear wires or linear wire runs, right? You actually braid them. Let's say you take two wires to a motor, you actually braid those wires together, right? And what it does, it cancels out the inducement from the other wire.
Gotcha.
Any changes in voltage in a line, it doesn't have to be a reversal of polarity, induces a field, and that field collapses, and it collapses not only on the original wire, but adjacent wires. So your braiding kind of cancels all of this out. It's kind of hit and miss, and the iron core just acts as a central focus or nexus point for these collapsing lines of EMF. So it's an inductive device, and its function is to, like a capacitor, to attenuate these spikes, which can get into other lines, particularly signal lines.
Because even though they're insulated, every wire has a field around it as it's going along. I mean, basic, electronics, right? But if you can cancel them out by braiding them out. So
Gotcha.
The two torpedo men have spoken.
Yeah. What do we?
I don't think we've touched on it before. And so if you've got a glitchy boat, it could very well be that you've got, some like EM interference going on with your signal wires. So this could be something that you might want to invest in. It's super cheap. If you hop on Amazon, you could probably get about like 800 of them for a nickel or something like that. And just clamp them on your signal wires. I was utterly impressed with the clamp-on unit that I put in the Virginia. It completely solved the issue with the glitchy ballast. So just bear that in mind. We're operating in a very, very enclosed environment. So all of your wires are working in close proximity to each other. So there's EM fields that are all messing around with each other. So if you're going to do things, set it up properly and get some ferrites in there, or as they said, at least braid the wires so it's not a straight linear shot to create the maximum opportunity for interference for the cables.
I wonder if that was Logan's problem with that submarine that he was working on. I had told him separate the speed controller, because sometimes if the receiver is too close to that, and he did that and it worked. I wonder if he was coming up, experiencing the same thing.
That could be. That could very well be. Yep. And I guess the telltale sign that you've got an issue like that is when one feature activates when you're trying to utilize another one. It'll be, particularly your main drive motor. That's your main power sucker, right? Your main drive motor, or pumps. If you've got air pumps, if you've got water pumps, those are high draw, high current components inside your watertight cylinder. So when you kick those on, that's going to be when you're going to get maximum EM interference occurring within your watertight cylinder. So that is going to be your clue. If you're kicking those on and it starts doing weird stuff, that you've probably got some interference issues and you should look to rectify. Okay. News from the Drydocks. We are into August. We're like halfway through it. September is going to be crazy. The Nautilus Drydocks is going to be driving from Texas up to Groton, Connecticut, and back again. The first weekend of September for SubX 24. So if you look at Ray's background there, if he moves his gorgeous mug out of the way, there you go. In Groton, Connecticut. If you guys have not been, it's a really cool venue. You're on an actual bona fide submarine base. And I don't know what they got planned this year. They've been super tight-lipped. I don't know if we're doing sub tours or if we're going to have a poker tournament or what's going on, but it's always a lot of fun. Even last year, I believe there was a torrential downpour and they still had a good time. So I will be going there. And the part of this, the reason for driving is I'm going to be picking up
The photo boat.
a boat in Pennsylvania, dropping off another boat in Pennsylvania, and then running there and driving back. And the reason for the vehicle as opposed to shipping is because the boat I'm picking up is like 10 feet long. So that's all I'm going to say about that. If you're going to go to Groton, you're going to get a chance to see it. It's going to be super cool. And it's got a really, really awesome history at that specific event. So if you've been going there for a while, you may recognize it. And by a while, I mean like decades. If you've been going for like a really, really, really long time.
Can I ask a question that might give it away?
I reserve the right to not answer, but go ahead.
Was it once painted pink?
I couldn't even answer that. I have no idea. But it was storied, I guess. It had a boatload of features, and apparently it was well regarded. The owner himself passed away quite a while ago. The family is selling it to me in the hopes that eventually it will find its way into the hands of an individual that will really, really appreciate the history and the work that went into it. So I'm going to leave it at that. I will hint that if you're a fan of World War II U.S. submarines, this will be of interest to you. And then, of course, I get a little break for like a week, and then Subvest 2024 is going to be an absolutely awesome event. The registrations are taking off right now. This year, I think more than previous, they're going to be very, very intentional about making sure we got clear water. I'm not guaranteeing anything because it's out of my hands, but they said they're going to look after us for crystal clear spring water in Kahana, Georgia at the Red Clay Resort. So if you're on the fence, you know, this is the event to go to. It's like 4 days of RC submarine focused awesomeness. If you got surface craft, they're more than welcome as well. We're not discriminatory. You just may be relegated to a certain area of the pond when we got expensive submarines cruising around.
Target services.
Targets. You can't have submarines without targets. I heard a rumor that there may be a 15-foot Titanic. I'm just saying, there's a rumor. If you got torpedoes, you can't miss. It's 15 feet long, people. You can't miss.
Bring a paintball gun. You hear that, Frank?
Yeah. That's childish.
Yeah.
Working torpedo.
Like the sunken, and they can have it on the bottom. We can go down and look at it.
Yeah.
Okay. All right. I want to make sure we have a chance to go through this. So we're 15 minutes in. Let's talk about brushed and brushless. So everybody is probably familiar with brushed motors. They've been around for, God, what, centuries? Like a really, really, really long time. Electric motors. Same technology, same idea is basically unchanged. Still utilized in selective applications in industry, in hobbies and that sort of thing. But what we're seeing right now, especially in our hobby, is a little bit of a migration or an evolution towards acceptance of brushless motors. So I want to take a chance just to make a high level overview. This is super high level. I am not a motor expert, but this is the information that I plagiarized from the internet. And I will pass along to you individuals, and then we're going to open it up for discussion with your experience with these motors and the applications for us in the hobby RC submarines. So with that said, is this visible?
Yeah,
Okay. Brushed, brushless. I have to say the brushless motor looks much cooler than the brushed motor. It wins just on cosmetics. Pros and cons. All right. Specifically talking about our applications. So
That's the same.
this is like a little master table. I'm going to go into each one of these like topics in depth here in a moment. Realistically speaking, there's a lot of advantages of evolving towards a brushless solution. They tend to be, you know, a little bit less maintenance. They tend to last a little bit longer. They're much more energy efficient. They tend to be a lot lighter and more compact. So if you're building the little baby boats, like some of you masochists like to do, that's a good solution for you. You get a smaller footprint in there. They generate less electrical noise, like we were talking about, but they are at least quintuple the price of brushed motors. All right, so let's jump into this. So maintenance, brushed motors. So the way that these works, you got this commutator, and it rubs up against the brushes. Commutator up in the front here, and it's rubbing up against these little brushes. So you've actually got like a physical contact going on inside there. Eventually, they're going to wear out. It has to. You know, they're rubbing on each other. After a really long time, you're gonna get stuttering and you know, other evidence of potential upcoming motor failure. Now, if you're, again, a masochist or really cheap, and I mean like really cheap, like Dave Merriman cheap, you can replace and refurbish the brushes on these motors, but for the most part, like if you're ordering these things in bulk, you can probably pick up like a bag of brush motors for like $10. So if you're considering refurbishing your electric motor, you're really valuing your labor at a very low rate, like a nickel an hour or something crazy like that. The brushless motors require less maintenance. But more has to do just with the bearings. That's the primary source of friction inside. Everything else is just like fields interacting with each other. So even if you look after them, brushed motors, they will not remotely operate as long as brushless. The copper is the primary component of the commutator. And eventually it's gonna wear out. Now take a look at these hours. Now we're gonna put a little grain of salt, drip the salt in there, take this information with a grain of salt. 1,000 to 8,000 operating hours. If you're getting 8,000 hours on your submarine, you're doing something right with your life. You've done something correct when you've built your RC submarines. If you've operated it for 8,000 hours to the point that the motor is no longer functioning. For our application operating life, I would say is probably not a major consideration. You know, if you're out at the pond half an hour, maybe an hour. No, let's go crazy. Let's do Ed Portal crazy. Let's say you go periscope depth for 3 hours at a time, twice a month. You know, you're looking at 6 times 12 6 hours times 12. Let's say you're at 100 hours a year. You're talking about like 80 years of operation before you need to worry about this kind of stuff. But now we're getting into the nitty-gritties. The gritties of the nitties. They are more efficient, brushless motors. We're talking 75 to 80% versus 85 to 90%, because there's less friction. less heat, less electrical noise. I thought this was interesting. Brushless handheld power tools, like cordless drills and that kind of thing, 30 to 50% longer on the same battery charge. That's significant. Would you want to be able to drive your boat 50% longer on a charge before you need to bring it back in and charge up your battery? Yeah, probably, right? Probably a really good idea. Now, speed and acceleration, if you guys are into like drones and airplanes and helicopters, this is really, really important. For us, maybe not so much, but brushed motors, they can only go so fast, right? They've got a physical connection. Like the faster you go, the more those physical connections are stressed. And you've got a large amount of iron in there that has a lot of inertia. So if you're going from full forward and you're blasting along at 10,000 RPM on that motor and you slam it into reverse, there's some significant mass that you've got to stop and then kick in the opposite direction. Brushless motors, not so much. The speed and acceleration is significantly better. Now, again, time for some salt. Take a couple grains and sprinkle it on what I just said. We are not racing submarines. To use the Ed Tortle analogy, he is cruising at 25% throttle for 2 hours at constant throttle and constant depth. Unless you've got a high performance, high speed submarine, this is probably not a major point of concern for you. Torque is torque. The torques are the same if you've got brushed or you've got brushless. Torques are just torques. Brushed motors, they don't have the same degree of finesse that the brushless motors have. I don't know if you guys have ever had, like the new, like rotary hand tools. The older versions, when you get into it, when you really put your elbow into grinding something down, the RPMs will drop. But with the new motors, the new motor sensors, the new motor controllers, as you put your juice into it, it'll just simply increase the power in order to keep the RPMs constant. So that's an advantage of that system. There's just finer controls. They're more precise. And as again, as you increase the demand on the motor, they can increase the power to accommodate, so they can basically increase the torque that they're providing in order to accede to your demands.
Hey Bob.
Yo.
Just want to make one comment on that. One difference between brushed and brushless, right, is with the brush motor, to change the speed, you actually change the voltage. With a brushless,
Correct.
the voltage is constant. It's just how often that voltage is applied. And that's important because you need to make sure your motor and your speed control and your battery all line up. You can't.
Correct.
Like with, okay. With brushed,
Yeah, we'll go into that. No,
voltage
that's a super good point, and we got a little slide.
Okay.
Like four or five down here that we'll ping the peanut gallery to chime in on.
Okay. Sorry.
Yes, good point. Thank you. Weight and size. Brushless motors, more power in a smaller package. Again, you crazy masochists, when you're building these 96 scale boats, 1/144 scale boats, the little like toothpick sized submarines that you crazy people decide to operate, this is advantageous for you because the motor size is much more applicable for your application. Even if you've got a big submarine, my first boat was a 66-inch Nautilus. The motor was 3 inches diameter, 4 inches long. It was a big brushed motor from a blower from a vehicle, from a car, for the HVAC system. Nowadays, you could probably get the same power output from something a quarter of the size. So the efficiency, you know, the size that these are that you're available to take advantage of is better for us now. Of course, if you're running a massive submarine, maybe size isn't a huge consideration, but this all comes into play when you're designing your boat. Noise and vibration. This is probably one of the biggest things. Brushed motors can be noisy. And when we say noisy, I mean, there's like noisy, like, you know, for your ear noisy, but there is also electrical noise, which is much, much more imperative in our application. You know, these brushed motors, they're actually brushing over. They're making a little switch on off at 10,000 times per minute or whatever. Arcing can occur at the contacts, which is super exciting if you're charging like sealed lead acid batteries in an enclosed area. These can really stimulate your day if you power on a brushed motor in a highly concentrated hydrogen-rich environment. But you've got electrical noise and even heat that is generated in these motors. Now you can, and we do, solder in capacitors over the leads. That can help mitigate it, but there's always going to be some in there. Okay. The interesting part about this, that the torque curve on brushed motors is not constant. It pulses at a very, very high rate depending on what stage of engagement the brushed motor is currently at. They call it torque ripple, quotation mark, right here, apparently. I didn't know that, but now I do. Mechanical pulse of energy causes vibrations and noise, especially at lower speeds. That's where you, like when you're, you know, when you hold the motor and you goose it, you can hear that brrr as that motor is trying to go. Brushless, quieter, less vibration. Cost. Of course, this is a massive issue for us because, you know, these motors are such a high percentage of the cost of RCSubmarine, quote unquote, sarcasm bracket. I don't know if you caught that or not. That was my sarcasm voice. You know, it's like the difference between a $5 motor and a $25 motor. You know, okay, it's 5 times more expensive, but in the grand scheme of the expenditures that you're putting into your RCSubmarine, it is not significant. It's like 0.05%. This is not a massive consideration. So, but it is one. You know, they are more expensive, and the actually, I shouldn't even say. I was going to say the electronic speed controllers for them are more expensive. I don't know if that's actually true. Now, I think you can pick up brushless electronic speed controllers for dirt cheap now. Probably as cheap or cheaper than brushed electronic speed controllers. This technology, brushless motors, invented in 1962. 1962. That's a long time. It's like, what is that? Like 60 years ago, 62 years ago. But that having been said, just because of how brushed motors have been embraced, it's just a small percentage compared to brushed motors. And it's fairly new, you know, that not a lot of people are familiar with the technology and you know, how they're used. The other thing that was noted in this article, which I thought was interesting, is brushless motors. They're more likely to have higher quality of materials, more expensive materials embedded in the creation of the actual motors, unlike brushed motors, which are basically today, let's be honest, manufactured purely due to cost. It's a cost deal, right? All right, application, brushed motors. Where are they used? Homes, automobiles, power tools, industrial applications, mostly in industrial settings now. Everybody has really kind of migrated towards brushless. You can change that torque to speed ratio with like different windings and that kind of thing. They're pretty versatile. But the primary reason that they're out there is because they're cheap. Cheap. I bought for my little 200 series sub driver, I bought a bag of 5 motors for $9.99 off of Amazon. So we're talking epically cheap here right now. You know, they're manufactured in China for a nickel for 150 of them. Brushless, basically, if we're talking about anything that requires efficiency and reliability, everybody's migrating towards brushless because, you know, it was a factor of over 10 in terms of longevity for these motors. It's a higher initial cost, but lower maintenance and less failure. So when you're choosing if you're going to go brushed or brushless, if this right here, this is the thing. Whoop, back up, back. Oh my God, I broke it. Dang it. I know what I'm doing. Shut up. Now I went too far. Hold on. We got this. Apparently I can't go back. Wait, size, configuration, cost, application. Okay. If the motor will be used less than the service life of the equipment, it is best to use the more affordable brushed motor. This is back to what we were talking about before, people, 1,000 to 8,000 hours. If you think you're going to be operating your RC submarine less than 1,000 hours before that boat requires complete refurbishment, a brushed motor is perfectly fine. Unless the performance characteristics and efficiency are a massive consideration for your application. Okay? They're doing the same thing. They're spinning the shaft. Okay, controlling the motors. How are you going to control these? These are two different critters. You cannot use a brushless electronic speed controller to power a brushed motor. You cannot use a brushed electronic speed controller to control a brushless motor. You know, with a brushed motor, you can jumper that bad boy. You pull out the wires and you jam on the terminals and you see if it'll spin, right? You can't do that with a brushless motor. I've never tried it. I think interesting things would happen. I think somebody should do that and put it on YouTube. I think that would be really exciting. But it's not going to work very good. Maybe if you do it super fast, I don't know. Brushless ESC, I'm going to note this: 1, 2, 3 wires for the motor versus 2 wires, the yellow and the blue here in this particular example, for brushed motors. So they create a 3-phase alternating current power, variable frequency drive. That's how they operate. Brushed, they're doing is just changing the voltage. They bump up the voltage to make it go faster, and they bump down the voltage to make it go slower, or they reverse the voltage to make it go backwards. You can't switch them out, okay? So you need the dedicated brushless electronic speed controller for brushless motors, brushed or brushed. All right, so that's all fine, right? Now we're getting into the gritties of the nitties. How do you know which one to get? What do you put in your boat? How do you know which one to use? Primarily, we're going to be using this for propulsion, all right? So RPM is a massive consideration. You want to consider what your RPM RPM range is going to be. typically the smaller the boat, the higher the RPMs you can get away with. The bigger the boats are going to be operating on at lower RPMs. Dave probably knows even better than I do what those particular RPM ranges. I'm going to guess, Dave. I'm going to throw a number out there. Correct me. Maybe small boat like a 96 scale, something or other, like a blueback, maybe $5,000, 5,000 RPM on the upper end. Does that sound about right?
I'm gonna rain on your parade. I don't care a bit about RPM. My criterion to size a motor to a particular application is the old German method. If the propeller diameter is equal to or slightly less than the can diameter, you got a good match. Period.
Okay. That's a good rule of thumb for you're talking brushed motors, correct?
Yes. Yes.
Brushed motors.
Yeah, no, if you're talking to me, we're talking brush motors.
Yep. So I will still say you probably want to consider RPM range. Now, a lot of brushed motors at 12 volts are going to be running at 10,000 to 15,000, sometimes 20,000 RPM. That's a lot of RPMs, guys. That's probably too many RPMs for your boat. That's why a lot of people will go with a geared reduction drive, a belt drive, or something like that. You get really exceptional low RPM control over that, because you're basically taking 10,000 and in a 3-to-1, you're dropping it down to 3,000, et cetera, et cetera. Physical limitations obviously are another big thing. If you got a little boat, you can't put a big motor in there, even though it would be awesome because it wouldn't need to work at all to make it go. It would probably draw next to no current. You just don't have room for it. And then you need to control these things. So your speed controllers, the rule of thumb is at least 20% higher capacity on your electronic speed controller than what you're ever going to draw with the motor. So if you check the motor specs and they're saying 10,000 RPM at 3 amps maximum current, you're gonna for sure want to go probably at least a 10 amp electronic speed controller. You don't want to put a 5 amp speed controller on a max 5 amp motor. You need to have that buffer in there. And this is the same rule of thumb for brushed and brushless. Okay. Now, this is where the witchcraft gets in. I'm not entirely sure, and I didn't have enough time to figure this out. Maybe Nathan can chime in on this. Sensored versus sensorless motors. I don't know the difference.
If I understand properly, that means the ESC can read back the RPM.
Oh, and so it can just basically make sure that, hey, I told you to do this. You're doing the correct thing, therefore we're cool. I told you to do this, you're not doing the right thing, therefore I'm going to modify my outputs and we're going to try and figure this all out.
Yeah, I believe that's correct.
And
I've never
I can
used
chip
a sensor motor though, or ESC.
Right.
I can chip in there.
Okay.
Censored motors have Hall sensors in them. So
Okay. Yep.
the Hall is actually logging the rotation of the motor versus no sensor. The speed controller is counting its own pulses. So it monitors itself, but it really doesn't know what the heck the motor's doing.
Yep.
Censored, they put a Hall sensor on the shell of the motor, and now the speed control can literally count.
There you go. So realistically, in our application, maybe that would be a good thing, but it's not a required thing. I guess would probably be a good way of doing it. It would probably increase efficiency, I would imagine. The electronic speed controller can modify its outputs. Yeah, you got your hand up.
So I took a Gropner Sharp 500 speed 500 motor DC in it and put an equal size brushless in it as if it couldn't go fast enough. And I did do censored. And the reason I did censored is because I knew I was going to be overdriving it. And censored motors do better at low RPMs. When you want to control at the slow speed, that's when a censored motor works better. But I say that, but that was 8 years ago. And nowadays, I don't know if the technology's even improved that I don't even see censored motors very often anymore.
Yeah, you know, I would have to say I probably haven't either. With brushed motors, depending on, you know, the setup and gearing and all of that stuff, I would say low RPM is one of the drawbacks for brushless motors. They're definitely not as smooth, as linear, as torquey as brushed motors are in the low RPM band. And I think Steve, if he's still kicking around in there, I can't see him on my screen right now. He was struggling. I can't remember what boat it was. Maybe it was his big permit. It was fighting him at low RPMs, and so he had to goose it to get to get performance out of it. Otherwise, it would just kind of grind, like kind of slip, a little bit.
I know a little bit about that, if I can chime in.
Yeah.
So brushless motors obviously are super common in RC airplanes and RC cars. Both things that are mainly meant to go fast. An RC airplane, propeller's never spinning slowly. So in cars especially, when you get that funny syndrome, and it's because of the sensors you guys were just talking about, a sensorless brushless motor, it has no idea what the speed control has no idea what the motor's doing. It's just counting the pulses and going around. And when you try to go slow, it does that jerky motion. They call that chugging. And in cars, it's real common. If you try to go real slow with what would normally be a high-speed RC car, it'll just kind of jerk around until you goose it. So, and that is a little bit of a problem for submarines because most of our scale models, we want to go slow. So we don't have that real slow, fine control with a sensorless motor.
Well, there you go. So I guess if you're shopping, it would be a really good idea. And I can't think the price differential has to be massive, but if you take a look for a censored motor and a censored electronic speed controller, you may get better fine control at low RPMs. The other thing to think about for brushless motors in terms of performance, there's two things that kind of make up the motor. There's a kilovolt rating, and then there's like turns of the windings in the brushless motor. So kilovolts determines RPM. So if you guys have seen, if you've not messed with these before, you'll look for a brushless motor and it'll have a kV rating. Could be 350, 500, 750, 1100, could be 2000, could be anything. Take your voltage that you're going to be driving at. So let's say you've got a 12-volt battery. You would multiply the kilovolts by 12, and that'll give you the theoretical maximum RPM of that brushless motor. All right, so that's how you would torque it, or how you would calculate it.
And where do we want to be? Where do we want to be in the submarine hobby? I struggle with this.
I would say definitely under 6,000 RPM in my experience. But again, it depends on the scale of your boat. You can get away with faster RPMs in smaller boats. The bigger the boat, the bigger the prop, the slower the RPMs you're going to want to be operating at.
Hey,
Thank you.
Bob, everybody, there's other factors with brush motors, right? Just instead of, the ones that are just straight off the shelf, because in vehicles, we use ones that, let's say like a 400, right? But then there's also ones that are long cans, right? And they induce more torque. There's also steel bands that we put on them, right? That induce more torque. Right, this is stuff that is outside choosing winding, right, which has a big factor how you can wind for thrust, of speed, for torque. and all these things. There's a lot more, you know, to choose on a brushed motor
Number of
than
poles.
just, you know,
Yeah.
like for instance, like with the aircraft people, they have a lot of motors. Like I remember the company Zaggy had them, and we thought we were going to like them, but they were only wound for high thrust one way. The other way it didn't work because the aircraft, you know, props only work one way, right?
Right.
You
Motor
know,
type.
yeah. So it's, you know, there's a lot of things where you can choose a motor, you know, that's the same size, but the actual can or, you know, things, the attributes about it are going to provide you more torque.
So there's a lot going in, and there is a certain degree of witchcraft, I suppose, involved. In our application, torque is important. We talked about this before. You know, we're not moving air, we're moving a liquid. It's exponentially more dense. And so torque is a big consideration. If you're going from full forward to full reverse, you know, that's a lot of stress on the motor. So torque is really important. In my experience, for brushless motors, I've gone up to like 1,000 kilovolts, but you know, depending on the boat. I mean, I think I got my Type 7 up on plane with an 1,100 kilovolt pair of motors. Like it's ridiculous. You got to go into your programming to reduce the power to bring it down to a scale size. So you can drop down in kilovolts, you know, maybe 350 or 500 is more applicable, but now you're starting to lose low end controllability. You know, you get that bogging or clogging or whatever it was you guys were saying the actual term is in those motors, depending on how they're put together. So in practical application, that's the last slide I had. Does anybody have feelings, emotions, strong attractions to one technology over the other in our application? I'm going to reserve my comments until after I hear from you guys.
I have a
Shifted.
question. It may be for the beginners, Bob, for the next one. This is
Yeah.
informative about the difference between the two. Mine is there's a relationship, like you say, it's speed controller, the motor, okay, on that. But to me, is what size of motor is it? Because I'm sure there's many types of motors that you can use on that. So you talked about brushless, but if I'm using a 1/48 scale Type 7 German on that, what kind of motors, brushless motors, would I use in that? That would be relative to the speed controller, because I have a World War I sub chaser that I had purchased, and when it was running, it runs like a speedboat. It like literally just boom, whereas opposed
Yeah.
I was expecting to be very low. So someone was telling me, well, my battery is too big. So when I got the specs from the company of what it is, it still did. So then that tells me then it must be my speed controller, or I assume maybe the motor.
So I think as a rule, and again, you guys can correct me if I'm wrong, you know, think about it this way. You know, if you need to move your bicycle up a hill, right, and you put a weed eater motor in it, that weed eater motor is going to be working pretty hard to get you up the hill, right? So that'd be the equivalent of putting a small motor in your submarine. If you put a V8 on your bicycle, it'll idle up the hill. So if you can fit the V8 in there, it's probably a good idea to do that, because the stress on the motor is going to be exceptionally low. And you know, likely the current draw is going to be next to nothing. So I guess my thought, and again, everybody can chime in, put the biggest motor that you can fit in there realistically. It's much better to operate a big motor at 20% of its capacity than a small motor at 100% of its capacity.
I did that. I've done that twice now. Both times I was replacing the DC Speed 500 Gropner motor with a big, same size brushless. And it came up a little while ago. Low speed control is hard. The what do you call it? Bogging?
Bogging, clogging, yeah.
And then the third problem that we have to overcome is that, just like the gentleman mentioned, every other industry that uses these things for hobbies wants them to have high RPMs, and we don't. So I'm having trouble locating the sweet spot in brushless where I got a low KV and a high torque.
So I have had good luck utilizing gear reduction. So in my mind, this is what these motors were designed for. So if you've got a 3-to-1 gear reduction, and there are bolt-on planetary gearboxes for brushless motors that work exceptionally well. I think I may even have it in my favorite products on my website. So if you're at 12,000 RPM, you know, so 1,000 kilovolt motor at 12 volts, it'll drop that down to 4,000 RPM output at the other side. So your low speed response is going to be exponentially, well, realistically, 3 times better than what it was previously. My little steampunk submarine, the one that Vaughn bought.
Tiger.
No. Anyhow, it was a blue motor with a bolt-on that's what we did. We did a bolt-on planetary gearbox. The bolts all lined up perfectly and everything. You just literally bolted it on. It took about 18.3 seconds, and it dropped that 650 kilovolt motor, you know, RPM down to something that was much more reasonable. So again, that motor is working so much less to propel the boat. So you've got planetary gearboxes, you've got gears that you could use, like gearboxes, you've got belt drives. There's lots of options for that. In my experience, you know, using those 750,000 kilovolt brushless motors, they work okay, you know, especially if you're talking like a 48 feet boat. The motor, the props are only yay big, right? The low speed response is actually pretty good in those. The issue is when you've got big boats with big props, you know, 2-inch, 2.5-inch, 3-inch diameter propellers. Now we've got an issue spinning that thing around because it's moving a significant amount of water. So that would be the application that you really want to examine, the utilization of a gearbox or gear reduction of some kind.
I guess that is the answer. The gearbox gives us a buffer now where we can be 1,000 kilovolts out of spec, and still that's only 300 rotations that we're losing. So that's a great idea.
And it kind of opens up your availability as well. You know, finding low kilovolt motors is tough because everybody wants the RPMs. You know, they want the 2,000 and 3,000 kilovolt motors, and we want 500 kilovolt motors, but there's not a lot of selection out there. Now you can do 1,000 or 1,500 kilovolts, and it'll drop it back down into something that's more reasonable for your application.
Thank you.
Yeah, absolutely. Any other comments for brush versus brushless experience, utilizing them, frustration, successes? So that's what we use in our subdrivers is brushless motors. It's a small footprint, you know, in the cylinder. Having said that, we are using brushed motors in the new 200 series that we're going to be putting out, just because the footprint was there, the cost was there, and the low RPM performance.
Are you still able to source brushed speed controllers. That seems to be the next thing drying up.
Yeah, they are drying up for sure, but they are out there. And you know, of course, it depends on your application. If you got a big boat, you know, finding a 50 amp brushed speed controller is becoming much harder. But in my experience, like low capacity brush speed controllers are still out there they're all over the place, you know, like 20 amp, 15 amp brushed electronic speed controllers are kind of all over the place right now. And they got really cool ones out there right now too. So if you got like a dual prop boat, they've got a brushed electronic speed controller that you can combine both motors in, and it'll automatically mix your throttle inputs with your rudder, and you can get differential throttle and all sorts of cool stuff. That's what I used in the Flying Sub. And it's basically twice the size of a postage stamp. It's you know, really good, economical.
What I like about the brushless motors is sometimes you can't put the motor, my instance anyway, there's not enough room to make it dry. So you want to put it in the wet. And the brushless motors make it a lot easier putting it in the wet, because when you're done, you spray some stuff, some WD-40 on it, and you're done. You didn't take up any space, and it's just
good point, Frank. I'm so glad you brought that up because I totally forgot about it. Brushed motors can be run in the wet too.
Yes,
a lot of people will actually break their brushed motors in water. That's how they'll set the brushes after they do like a refit or a refurbishment on it. The life obviously is going to be drastically reduced.
Fresh water.
Fresh water, yes, exactly. Obviously, salt water is highly conductive and will do very, very interesting things to a brushed motor when you throw it in the wet. But brushless motors they're fine in the water. Now, I'm on the fence. I've done it both ways. You absolutely need to build into your pre and post mission lists proper maintenance of those motors. There's been a couple of times I forgot to lubricate them after I brought them out, and they seized. Not seized, like completely seized, but you got to massage them back into operational condition again. If you're not religious about using a water displacing oil with the brushless motors, those bearings and bushings can corrode and seize. So just bear that in mind. But let's jump back here. You can run brushless motors in the water. They're perfectly happy in there. If you're talking about like deep sea, like ROVs and exploration submarines, that's what they're running, is brushless motors, because, you know, obviously they're operating at about 800,000 atmospheres of pressure or whatever, way deep under. And if you're just operating the motor in the wet, it doesn't care if there's 80,000 atmospheres of pressure or 1 atmosphere of pressure. It makes no difference to them. But it does require a higher degree of maintenance and you know, work on your part to make sure that it operates reliably throughout the operational life of your submarine.
Now, I'm a newbie with submarines. I mean, not, you know, the Sea was my first submarine, and brushless motors are really new to me. Now, the only thing I don't, is there a point of contention or something adverse to brushless motors, because they're metal filings in water that they pick up, or some kind of minerals that are magnetic and they build up inside the brushless motors? Do you have to worry about that?
That's a good question. I don't know that. Yeah, John.
Stainless steel bearings or ceramic bearings, that's important. I've changed them out to do wet. They also make them now where they're epoxied windings. So they're like intentionally intent to be submerged in DC water and salt water. And those are good. But I've had trouble with outrunners that are swirling the water inside my wet hull, and I feel like I'm losing a whole lot of torque just spinning the motor in a fluid.
Yeah. Yeah. So there's two kinds of brushless motors. There's what's called in runners, which is where the central shaft is housed inside a stationary housing. So the only thing that's spinning really is the shaft itself. And then you've got outrunners, which are probably way more common because they're used on like drones and airplanes and that kind of. I think they're cheaper to manufacture is probably why they're so populous out there. But the entire outer housing is spinning. So to John's point, when you've got that in your boat, you've got this, for lack of say, an inch or an inch and a quarter diameter housing that's spinning in water. You're losing a lot of energy into moving water inside your boat when it should be concerned about moving water outside your boat. Now I don't know if that's like 10%, 20%, or 50%, but I don't know that it's a massive consideration. It's not as efficient as it should be. Let's just say that.
They intentionally make those outer shells on the motors to intake air and cool the coils, cool the
There you
winding.
go.
And so I've actually covered up the holes to try and prevent it from literally sucking water into the shell, because
There you go.
it's not air, it's water. And no,
Yeah,
I don't know of any mineral deposits, but I just watch out for rust.
Thank you.
Bob, on the in-runner, outrunner conversation, I believe one of the benefits of the outrunner, which kind of fits with this conversation here, is that it has more torque and it's less kV. They designed the outrunner to be like a slower motor.
Oh, gotcha. So if you're looking for the super, that makes sense. Now that if I think about this, because I saw a whole bunch of super attractive in runners, but they're all like the 5,000, 7,000 kilovolt motors.
Yeah.
Which would be super exciting for our submarines.
I mean, our missiles.
Our missiles, yeah, exactly.
You can also change the shaft on an outrunner. You can take the shaft off and put a nice 3-inch shaft on something that used to only be a 1/4 inch.
Easier to work on. There you go. All right, last comments. Any other questions about that? The brush motors have been around forever, and I would say in our application, there's absolutely nothing wrong with them. I am still massively impressed with that first motor that I referenced before. It was a 10-pole internally suppressed brushed motor. And even at like full stall, I think it only drew like 4 amps or something like that for my first Nautilus. It was 3 inches in diameter, 2.5-inch diameter can. It was beautiful, quiet, smooth. So there's application in both ways. So just take a look at your specific utilization. Maybe bigger boats, maybe better suited for brush motors. Put a big old beefy brush motor in that thing and spin a 4-inch diameter prop with it. But for smaller boats, they're probably very well suited to brushless application, and you can get really, really efficient for energy utilization and battery capacity and that kind of thing for running those submarines. Okay, parting comments. Let's just open it up. General conversation. Anybody got any questions about what's going on with their projects before we kick you all loose? Everybody knows everything about everything. That's awesome. Okay, fair enough. Well, 2 weeks from now will be our next DiveTribe. I did want to mention I'm going to be much more intentional about favoritism with you guys. I started out with this Lafayette. You guys had 24 hours of first right of refusal for that Lafayette. So before I make those things public, you guys are going to have the first chance to take a look at them. And I don't care, honestly, if you buy it or you kick it over to your buddy and he buys it. As a DiveTribe member, you're still getting first right of refusal, basically, for lack of a better term, of all of those boats, just because they're in high demand. You know, there's going to put them any other way. RTR boats or new kits or you know, things that come across the Drydocks. So you get first pick at the can for those.
Thank you very much.
Yeah, absolutely. Okay, I got nothing else. All good? It was good seeing you, Rob. Have a great rest of your weekend, and we will catch you next time.
Thank you, Bob.
Okay.
Take care.
Bye, everyone.